Hello, so welcome again. In this particular session, we are going to talk about one new architecture pattern, that is hexagonal architecture. Somewhere you might be find a different name like port and adapter pattern. So, as you know, this was proposed by the Alistair Cockburn. And what is the idea behind this? So, this is one of the most important concept in the modern system design. So first we'll start by understanding the problem with the traditional architecture. So then move to the core idea of the hexagonal architecture and followed by the ports, adapter, and flow, and finally what is the benefits of that, right? Okay, so in traditional system, you might have seen business logic is tightly coupled with the database, UI, and your framework, right? And this makes system hard to maintain, test, and evolve. For example, if suppose my database I'm using MySQL, tomorrow if I'm going to change my DB, so of course this is going to impact the repository layer, right? So this model view controller MVC pattern, a three-tier architecture, is going to be broken, right? And testing will again become difficult. So what is the core idea of this particular hexagonal architecture? So hexagonal architecture solve this by isolating the business logic from external system, and we achieve this by using something called port and adapter and port. Okay, so this is a different pattern you can see. So there are two parts in this. One is which is reside inside the hexagon, and one is which is outside of the hexagon. So inside the hexagon you are going to write the core domain, a core business logic that is completely independent of any outer side of the applications. So, and in the outside of the hexagon, you can find DB, APIs, integrations, queues, or downstream APIs integration, right? So this is the way it is get separated. So it's a kind of visualize your application is kind of hexagon, and at center of this is the business logic, and outside of the system you are having all these component like DB, API, UI. Okay, so all the outside of the system, they don't talk directly to the core system or inside the hexagon. They have to go through ports or adapter. Okay, so, so let's do one thing. I'll draw one picture to understand more. Let me draw one picture. So earlier in traditional, what we were doing, this is our model. We call it UI. Sorry, we call it our logic. Okay, and this is the database. Okay, and in between we are having our controller. Okay, so let me talk about model view controller, MVC pattern. So this was the view part. This is your service or application. Okay, some multiple instance could be there. Okay, and this is a database, right? It's a model, controller, and this is the database, correct? So we also call it three-tier architecture, correct? So problem is that if for some reason you are going to make any changes in this, is going to impact your service layer or controller, because in controller in the application you are having one repo layer which directly call to this database, right? So changing the DB is going to break the logic. So what is core idea behind this? So it says hexagonal, whatever your core business logic is there. Okay, so in this hexagonal, whatever your application core logic is there, that should be inside this hexagon, and other application component, it should be somewhere here. So maybe this is your UI, this is your DB, this is your API dashboard or API integrations, and this is something queue is there, suppose for messaging. Okay, so all these outside of this hexagon, and they cannot connect directly to this caller. They have to call one port, like 8080 is a port. No? In the same way, port is a kind of interface here. They connect to that. Okay. So this is how they communicate. Okay, so outside of the system, that is UI, API or DB, they don't directly talk to the core, they go through ports, right? Now let's understand what is the port. Okay, so port are interface or contract. They define how the outside world communicate with the system. So it's a kind of one interface which is going to define how this communication should happen. So there are two types of ports. One is the input port and one is the output port. Okay, what is the input port? So input port, like the no, your use cases, right? So use cases you can understand, like uh, like what are the functionality that your application is providing to the users. Like suppose in e-commerce application, create order. So create order is a input port. In the same way, what is the output port? All these are output ports, like DB connections, okay, API integration. These are output ports, right? So you can say it's an external interaction. This is also called external interaction. All right. And this is your functionality that you're providing. Okay. Okay. So hope you understand this. Now coming to adapters. What are the adapters? So adapters implement these ports. So adapter is nothing but it's an implementation of the ports. So inbound adapters bring request into the system. When I say system, means your hexagon. Okay, so whatever coming from the outside, that is called inbound adapter. Okay, and what is going outside, I mean this is a port here, whatever coming to the port, that is inbound adapter. What is going out of the port, it is called outbound adapter. Okay, so outbound adapters connect to a database or API. Inbound adapters bring request into the system, like to the controller. Okay, so what should be the flow now? So the flow should be like that. When users send a request, adapter is going to receive that. Correct? Once the adapter receive it, is going to call the port, appropriate port, right? And then port is going to execute the business logic. Means this part is going to be executed by this. This is the main your core business logic, called core business or hexagon, you can say. Then it is going to execute the hexagon. And then again it is going to call another port. Okay, and this port is going to, I mean, talk to the adapter, right? Again, adapter like DB or whatever it is. Okay, so in this, so I want to just add one more point in inbound adapter. So inbound adapter going to bring data into system, right? So like whatever the REST controllers you are writing, right, and UI or some CLI command, all these are inbound adapters. So when a user call an API, a controller act as an inbound adapter, and outbound is nothing but any information that is going out of the system. So like database implementation or external API which is sending the data, right? So these are the concept behind this. So when user is coming, this user is going to call the REST controller, right? And we are calling this adapter, inbound adapter, you can say, right? And then it is going to call some method like create order, like that, use case, right? So use case are port. So this is input port. correct? And then this is going to execute the business logic, right? So this is all about, let me draw one picture of this. So here it is, your core logic, the hexagon I'm talking about. So this is the core domain, correct? I mean, all the business logic is written in this particular domain. Now it is connected to the input port, correct? Then I'm going to get adapters, okay? A request is coming, so I will write here inbound adapter, correct? And this is your you can say web REST API, okay? Once this is done, reaching to the core domain and get executed, after that what happened? You are going to call output port or outbound port, right? And this output port is going to be implemented by outbound adapter. So there can be multiple adapters. So suppose this one is the DB adapters, okay? And this could be some queue adapter where we are sending some notification, right? So this is how architecture it looks like, okay? So now you can understand, if tomorrow if you're going to change this, it's not going to impact your core domain, because whatever changes you are making, I have written an adapter here. This is the adapter, right? So if suppose DB today is MySQL and tomorrow we are going to change to Oracle, then adapter is going to be changed, not the core domain, right? We know that, like, what is the interface is a contract, right? So interface is used for this, right? So at the center we have one core domain which contain the business logic, and at the top we have input ports which represent the use cases like create order or whatever functionality that we have provided to the user, and they are accessed via inbound adapters like REST controller or some UI, right? And at the bottom, if you see, we have output ports and which define the interaction with the external system, and these are implemented by the outbound adapters like database or API. So this is what adapter patterns we have used. So this is all about this particular pattern. So let's draw, like, what is the benefit of that, right? Loose coupling. This is the first and foremost. So loose coupling. So hexagonal architecture remove the tight dependency between the business logic and external system. It means core logic doesn't depend on database, UI, or framework, right? You can change anything outside without breaking the core. All right. I have one example that I ask you about the MySQL to Oracle, right? So no change in the business logic. Second, high testability. What does it mean? It means since the business logic is isolated, right, from the outside of the applications or dependency, so it becomes very easy to test. You can test without database, you can test without APIs, you can use simple mocks operations, right? Testing frameworks. So it's become very easy. So because you don't require a real DB in this. Third, technology independence, you can say. Technology independence, right? Means core could be in any language, right? This is the main point. Core system is not tied to any technology stack. You can change from Spring to Micronaut or REST to GraphQL or SQL to NoSQL. No impact on the domain logic. So that's why it's become very easy to maintain. Because even though you are going to upgrade the technology, it's not going to impact anything. So I'm sure that you have got the point. Like, due to this clear boundaries and organized structure and independent modules, this has become very nowadays very demanding architecture pattern that people are adopting. And you can easily extend this system by adding the new adapters in existing applications as well. So, okay. So it, and one more thing, it's providing a very no better separation of the concern as well. Each layer has the clear responsibility. Core has a very clear responsibility. It's not going to depend on anything. Ports are having the different responsibility, like contracts, and adapters are nothing but it's the external communication interface, right? So which are implementing the ports. So very cleaner design is there, right? So I can say hexagonal architecture improve the system design by ensuring the loose coupling, high testability, and technology independence, and it isolates the business logic using ports and adapters. And that's why it's making the system more flexible, maintainable, and future proof. Okay. So hope you must have understood this and enjoyed this new design pattern. So let's see you in the next one. Thank you.